Hey guys, so today it's April 13th. You guys had a long weekend, so hopefully you're well rested and ready to jump right back in. So last time we were talking about corresponding sides of similar polygons and those being proportional. Today we're going to recognize and use proportional relationships of corresponding angle bisectors, altitudes, and medians of similar triangles. Oh, and also using the triangle bisector theorem. Okay, so here's a couple of theorems. These are in your textbook if this is too small for you guys to see. So this first theorem is, these are all special segments of similar triangles. So this first one is saying if two triangles are similar, the lengths of the corresponding altitudes are proportional to the lengths of the corresponding sides. So all that's saying is we're given that this triangle ABC is similar to triangle FGH, and we've constructed these corresponding altitudes, so those altitudes will be proportional to the sides. Okay? The second one is saying if two triangles are similar, then the lengths of the corresponding angle bisectors are proportional to the length of corresponding sides. Okay, so this is that same concept. We're given that these two triangles are similar. We construct these corresponding angle bisectors. Those will also be proportional to the sides. Okay, this last one says if two triangles are similar, then the lengths of the corresponding medians are proportional to the lengths of corresponding sides. So same concept again, but now we're talking about these corresponding medians. We're already given that the triangles are similar. Now we're just kind of taking these proportional parts from them. So let's apply some of these. Oh, just kidding. Here's a proof of one of those, but it's in your textbook. You guys can take a look at it if you want. Okay, so here we're going to use special segments in similar triangles. So we're given that triangle LJK is similar to triangle SQR. We have to find the value of x. Okay, so we're going to set up some sort of proportion. Okay, well, it looks like we're given, we've got these two are congruent, these two are congruent. Looks like we're going to use that medians one. Okay, but notice this. Here we have 5, and that's what this short segment is. And here we have x, and that's what that short segment is. You would think that we would take 5 over x or x over 5, doesn't matter. But that's not what the theorem is saying. The theorem is saying that we're using the median and one of the sides, where this isn't a full side of the triangle, okay? So we're gonna double that because these two are congruent. I hope that makes sense from home, okay? So that's what this is talking about. So we're gonna set it up. So we had these segments in the triangles. I'm gonna go ahead and plug them in. So this was our x and 5. Like I said, we were gonna double it so we have that full side, okay? I'm gonna apply the cross product property. Go ahead and simplify it. So we have 120 equals 16x. Divide that out so we get 7.5 for x, which is what we were trying to find. So x is that one side, half of that side. Okay, go ahead, pause your video, give this one a try yourself. Okay, so it looks like this one is using the altitude. Okay, so if we set this up, we should have 21, over, I'm taking this long side over this long side, x equals this triangle, 9 is the altitude over 6 is the other altitude. Okay, apply that cross product property, so then we get 21 times 6 equals 9x. Over here we should get 126 equals 9x. Let's plug that in quick. We get x equals 14. So at home you guys should have been finding that the answer is B. 14 is this value of x. Okay? Okay, so now here's a word problem. So we're estimating distance. So Sanjay's arm is about 9 times longer than the distance between his eyes. So we're going to stop right there. I'm just going to talk about what that means. So his arm this is 9 times longer than this. So if we were to create a triangle that went like this would be 9, and this would be 1. Okay, so that's a triangle that we're talking about there. He cites a statue across the park that is 10 feet wide. If the statue appears to move 4 widths when he switches eyes, estimate the distance from Sanjay's thumb to the statue. Okay, so that was kind of a lot too. So we have this triangle here that goes over 1, forward 9, right? This is 9. But then over here, there's the statue that's 10 wide. And what it means by switches eyes is, if you go like this a couple times, it moves the picture in front of you, okay? So if that's moving 4 widths, we want to know how far away the statue is. So they draw us a little diagram here. Hopefully you guys can see it. So here's our eyes. That's 1, right? And the distance to his thumb when he holds it out here, right, like his hand, is 9. Okay, so then there's this statue over here, and it's 10, say feet or something wide. And when it moves 4 times. Okay, so we're gonna, oh my gosh. Okay, so this is where we want to be. So we're taking these segments from those triangles, we're using those theorems that we talked about, and then we're plugging in the values for them. So we had 9 over x, that was this distance between me and then the distance in the sculpture, equals 1 over 10 times 4. And 10 times 4 was the width of that statue. So go ahead, we're going to simplify it, apply the cross product property, go ahead and solve. So we're estimating that the distance between my arm and that statue is about 360 feet. That was kind of a weird example, but we'll go with it. Okay, so here's another one for you guys to try. We're taking the same information about Sanjay's proportions, but now we're looking at a sailboat. So we still have that 1 unit between our eyes and 9 units out to our arm, okay? So now we're supposing that Sanjay turns around and sees a sailboat in the lake that is 12 feet wide. If the sailboat appears to move 4 widths when he switches eyes, estimate the distance from Sanjay's thumb to the sailboat. Okay, so I'm just going to sketch out our picture again. Okay, so this is still 1, and here I have 9. Okay, now there's something over here that's 12. Okay, but it moves side to side 4 times, or 4 widths. So we're going to take that times 4. And we need to know what this is. Okay, so if we set up the proportions, we'll have 9 over x equals 1 over 12 times 4 is 48. So 9 times 48 should be 432. So we should be getting B. That's 432 feet. Okay. So here's the triangle angle bisector theorem. So it's saying if an angle bisector in a triangle separates the opposite side into 2 segments that are proportional to the lengths of the other 2 sides. Okay, so what this is saying is we have to know that this JM here is an angle bisector. If we are not shown these congruence marks, then we won't be able to apply this theorem because it's not an angle bisector. So what this picture is showing here is we have this KM, which is a segment that's being created by this angle bisector. So if we have KM over LM, that proportion will be congruent to KJ, this red length, over LJ, that blue length. So let's apply this. Okay, so we have to find X. So here we have X down here and 6 here. 9 here, and 15 here. So if we take those lengths here, we have x over 6 equals, we're going to take the one on the same side, 15 over 9. Okay, now if we apply this cross product property, we take 6 times 15 equals 9 times x. 6 times 15 is 90 equals 9x. So x equals 10. So this value of x is 10. Okay? We'll just go through this. There, that's what we had. Okay, here's one for you guys to try from home. We're going to set it up the same way as we did that last one. So I'm going to take 5 over 7, these two numbers, okay? Set that equal to n over 21. Okay, if I apply the cross product, here we get 105 equals 7n. Now when I take 105 divided by 7, we get 15. So you guys should be finding b, n equals 15. Okay, here's your assignment. It's a pretty short one today. So we have page 505, doing 7 through 29 odd. You guys can skip 19, 25, and 27. Those are all proofs that we're not going to make you do. All right, good luck, guys. Have fun.